I'm going to tell you guys the hardest thing to talk with people about when it comes to Bitcoin. And it's actually something that's very simple. It's the SHA-256 hash. You just usually tell them, hey, this is the fingerprint of the data, and no one can change that. Except, unlike the graph theory properties and all these things we talk about with BSV, technically, that's not exactly proven. It's only believed to be true. It's kind of like the Collatz conjecture. It's like if you wanted to depend on it, you'd be like, yeah, let's depend on it. But that's because it's shown to be true to extremely large numbers. But nobody's actually proven. Nobody's actually proven it yet. It's the same thing with this. SHA-256 technically is just a secure hash. You can't prove in computer science how hard something is, which includes solving a hash. Like coming up with another file that gives you that hash, or reverse, I don't know, doing anything to break the security of it. Those are believed to be difficult. They're not actually proven to be difficult. Now you might say, well, what about all these videos where it explains that you need like a universe inside of a universe inside of a universe full of computers to compute these things? Well, those are that's explaining the best known method. Technically, you can't prove that that's the best method. It's just the best known method. And how many computers you would need. And there's nothing saying that somebody can't randomly come up on a file. It's, according to those numbers, statistically impossible in our universe that somebody would. And I mean that not for somebody, I mean that anybody in all of history would. It's still statistically impossible that that statement would be true, given those probabilities. But that's still assuming that that's the best known method. Now, when you talk to people about this, they'll question it, be like, oh, so that's not really secure then. Fine, I don't want anything to do with it. Well, my response would be secure compared to what? I mean, because if you actually understand, and this is the hard to explain part, okay? It's not about the 256, how big to the 256 is. It's not the fact that it's a fingerprint and all these things like that. This is the hard part to explain to people, is that that part is the ridiculous part when they question that. Because compared to what? I mean, if I built a system that depends on the Collatz conjecture being true, and then somebody questions, well, we don't know that it's true, so that thing could break, that thing could crash. Well, technically, like, it would have to be using numbers that are way beyond like these astronomically big numbers. If we're talking about it breaking when it reaches a number that such that the Collatz conjecture would not be true for. And if not, then why would it break? Like, anyway, but the point is, the likelihood, like the chance of somebody being able to break this with all these things like quantum computing and all this stuff still doesn't really make sense. There's something about it that shows that it's difficult. And then on top of that, you could, in theory, swap it out for a bigger one if you really wanted to. If supposedly SHA-256 is still somehow not considered military grade for some reason. But there's things that you can prove using math. Like, this statement is true. And then there's things that are believed to be true. Believed to be statistically impossible. And this is technically one of those things. But I don't really talk about it because I don't want people thinking like, oh, well, we shouldn't use that then. We shouldn't use something that we don't. Well, if that's true, I mean, compared to, like I said, compared to what? It's like, then, I mean, there's a chance that your television set could explode in your face. I mean, there's a chance when you go to the bank that the people constructing the building all made these perfect errors simultaneously. I mean, there's a chance of things that you've never heard of, never been presented in a movie, never heard about, read in a novel, and combine that with like getting hit by like, you know, a random meteor and all these things. Like, basically, it doesn't matter if you make decisions or not. Like, there's things that could happen. There's things that statistically are impossible that you could say, well, in theory, that could happen. I could get hit by 12,000 meteorites at the exact same millisecond, all of which are the size of something that has never hit the Earth once before. I mean, you could say it's more likely if there's a real like asteroid coming by and then those are breaking apart from that asteroid or something like that. But no, I mean by random chance. 12,000 randomly from space. Like, look, there's things that you can't explain because people won't understand the sensibility behind it. And the funny thing is when I argue with BTCers or explain why they're wrong, it has nothing to do with the hash function. We use the same hash function. So when they say Bitcoin is secure, they're making the same assumption about SHA-256 that BSVers are when they say that BSV is secure. The differences that they have to do with the graph theory and things that are easy to show. But it's definitely, I mean, like I said, you can't prove how difficult. You can only prove how easy. So if I solve an algorithm, if I have a method of basically breaking, like reversing a hash, give me a hash and I have an algorithm that produces a file from that hash. If somebody has that, all they have to do is post it somewhere and reveal that they can do things like that. So the public should find out if that was even possible. But there's also things about that would be a little strange. I'm just saying that it's not proven to be impossible. It's not technically proven to be impossible, if that makes sense. Now, I'm saying all this, and I'm going to go even further and say, I think you can't prove the difficulty. But I've always had this thought in my mind where I haven't fully grasped that concept. Because I kind of thought, well, what if you use a Turing model and you showed what's computationally possible given enough resources. So even if you had all the proper algorithms, you could prove that no such algorithm would be able to exist if it didn't have at least a certain amount of memory, which is kind of getting a little sketchy because you have to model it in a way to try to assume that. So you'd have to say there's no possible modeling. So I'm not even completely sure about the statement that you can't actually prove how hard something is, because there might be a way to at least sort of do that. But I don't